Archimedes' principle is all about understanding the buoyant force. And he realized the fundamental here. The buoyant force is equal to the weight of whatever fluid you displace. Now let's think through this. And what we have drawn here, this, if you imagine this cylinder of water here inside all of this water. So we'll just assume this is water because that's easier. Um, and you look at what's holding up this cylinder of water. Why doesn't this cylinder of water just fall to the bottom? And what you get is the force at the bottom needed to hold this up, or the difference in the forces on this, work out to be the weight of the water that's in this cylinder. And so that's how Archimedes got to O, or how you get to that the buoyant force due to water is simply the weight of the fluid displaced. So let's talk about where we see this all the time, right? I mean, because you really see it in shipping, and our recent shipping snafu in the Suez Canal is kind of interesting. Um, okay, so what what you see on ships, all right, like a ship, if you've ever been near the water, ships are typically marked with red or some other color to indicate um, how much they should be loaded, right? And so as you begin loading containers onto this ship, the water, it's going to sink further and further into the water, right? And so for every, you know, for every uh, kilogram of of uh, cargo you stick on this ship, it's going to sink and displace a kilogram of water. And so you can stack things up and stack things up, and eventually you kind of sink down into this line is sort of the safety line, because water, when you're out at sea, there are waves and things like that. And you don't really want to be too low in the water because then you get water in the ship, and when she gets water in the ship, you sink further and eventually you go under. Um, so it's really important, when you're loading things, you think, okay, it's the water we're displacing that's key here. All right, so let's ask a different question. What fraction of something how far will it go into the water? And so the fraction that's submerged really just has to do with densities. So the overall density of this ship, fully loaded, which is still has a lot of air in it, right? I mean, all these containers have a lot of air. Everything has a lot of air. It doesn't matter that iron itself, steel itself are denser than water because it's combined with a lot of other stuff that's not denser than water. So the total density of the ship divided by the density of water determines how far the ship goes down into the water. Um, and what we call specific gravity of a fluid is really just that ratio. The specific gravity of fluid is just the ratio, the density of, or the specific gravity of an object. It's just the ratio of the object, the density of the object to water, right? Um, and so this is how you kind of anticipate how far is something going to submerge, how far will a cork submerge, how far will other things submerge, and of course, if the density of the object that you're talking about is greater than the density of the fluid it's in, what happens? It sinks because this ratio becomes greater than one, which tells you it's under. Um, and so that's Archimedes' principle and how you kind of look at buoyant forces and how they work.